Alright, let's look at question 12. The quantity of 3 types of cakes sold on a particular day at 2 outlets. We can see outlet 1, outlet 2 of a cake shop given at the table below. So outlet 1 sold 60 butter cakes on some day, right? One day, some particular day. And outlet 1 sold 100 chocolate cakes on that same day, sold 40 fruit cakes on that same day. And outlet 2 sold 80 butter cakes, and so on and so forth. Unit selling price and unit production cost is given below. So each butter cake is sold for $8.80 at both outlets. So I think they don't. It's going to be the same at both outlets since they don't tell me otherwise. And it's sold. Each chocolate cake is sold for $10.80 and each fruit cake sold for $14.80. Production cost is how much it costs to produce the cake. So the outlet, it costs them $3.50 to produce one butter cake, $4.50 to produce one chocolate cake, and $8 to produce one fruit cake. All right. Now that makes sense, let's look at the question. Okay, they give us these matrices A, B, and C, and they ask us to find AB. Once again, and they ask us to say what the elements represent. Once again, I like to calculate it first, and then look at the working and try to figure out. So AB is this. Because if I just straight away try to see what it represents, to me it's not so straightforward. So I like to kind of do the working, study the working, and usually the answer will be clear there. So this part we've been doing many times, so I'll just kind of go through it pretty quickly. We end up with a 2 by 1 matrix. So 2 rows, 1 column, and this will be row 1, column 1, row 1, column 1. So okay, key all of that into a calculator, and what you get is this. Cool. And let's take a look at the working. So let's try to figure it out. So this matrix looks a lot like, it looks a lot like this table. This matrix A looks a lot like this table. Right, so this is actually the total number of cakes sold. And this looks a lot like, right, B, which is this, looks a lot like here. Can you see? 3.5, 4.5, 8. So that's the unit production cost. Okay, so I think that makes sense to me, right? So if you see over here, this is 60 cakes sold, and then 3.5 is the cost for each butter cake, I believe. Yeah, each butter cake. And then so this is the total cost of the producing, right, the butter cake at outlet A, total cost of producing chocolate cake at outlet A, right, on that same day. And total cost, the last one is the total cost of producing the fruit cakes, all 40 of them, right, at outlet A, all 40 of the fruit cakes. Yeah, and so we can say it represents. So this is the total production cost for outlet A, and this is the total production cost for outlet B. And so we can say this is the answer now. This is the total production cost for each of the outlets A and B respectively. Yep. Okay. That's part AI, and let's look at part A double I. Just gonna do it here. Okay, A and then C minus B and interpret the meaning. Okay, so that's pretty cool. But let's just write it down first. Quite different from some of the usual questions you've seen. Usually they don't have addition or subtraction in it. And this is A, and see there's a bracket there. So I'm going to put a bigger bracket, and then C minus B is going to have to be done first. This is C minus B. Yeah. So since this is in the brackets, you're gonna have to do this first, and then you multiply this matrix in after that. Okay, and so let's just do that. Yeah, so I'm just gonna leave this matrix here. Right, and here subtraction of matrices, so no multiplication moving around, no, right? This one minus this one, and this minus this minus this. And notice this is a 3 by 1, this is also a 3 by 1 matrix. That's the only way you can subtract. They have to be the same. And so once you subtract it, what you get is, this is going to be 530 and 6.3, and finally 6.8 over here. So I don't need these brackets anymore, right? They don't mean anything anymore because I've already done the subtraction inside. Now 60 here. Now I can multiply. So this is it's a 2 by 3. This is a 3 by 1. So my final matrix is going to be, these are the same. So final matrix is going to be a 2 by 1. 2 rows, 1 column. So this is 1 row, first row, first column, first row, first column. This is going to be, and let's create some space. 60 times 5.3 plus 100 times 6.3 plus 40 times 6.8. This would be 80 times 5.3. Okay, key all of that to calculator, and we get this. Cool. Now let's try to figure out what we just calculated. Over here, what is this? This is actually, if you notice, that is the selling price. So all the selling prices, you're subtracting the production cost. So this part, interestingly, actually is the profit, right? Selling price minus away the production cost. So this is the profit for what? 8.8 minus 3.5. So this is actually for the butter cake, right? Profit from butter cake. And then this one, 10.8 minus 4.5 is the profit for chocolate cake and profit for fruit cake. Yeah. So there's profit for butter, and this is actually profit for chocolate. And this is actually profit for the last one, which is a fruit cake. Yeah. That's cool. And then you're multiplying each of these, which is the number of cakes, right, sold by the respective profits made. This for outlet A, outlet B. So really, this is basically the total profit at outlet A, and this is the total profit at outlet B, right? So we can go a bit slower. So this is the profit, for example, this is the profit for butter cake, and here you sold 60 butter cakes that day. So total profit for all the butter cakes, plus total profit, right, for all the chocolate cakes at the same outlet, because you sold 100, right? You sold 100 chocolate cakes at the outlet, and this is a total profit for all the fruit cakes. So this is total profit, basically, for A after selling all the cakes. Yeah, and so we can say the elements represent the total profit at each of the outlets, A and B respectively. So C, yep. And right now let's go to the last one, B. Okay, D is this matrix, and E is that matrix. So let's find it. Okay, let's do it here. DE is simply this. 3 by 2 matrix, 2 by 1 matrix, same number. Final matrix will be a 3 by 1 matrix, which is 3 rows, 1 column. So let's do first row, first column, first row, first column. 60 times 1 plus 80 times 1. Second row, first column, second row, first column. And finally, for the third row, third column, add it all up. Cool. And what is this really? Let's look. Over here, it actually looks a lot like this. In fact, it looks a lot like A, just that it's kind of like a different format, right? It's kind of a different format. But when we look at it, what we're doing is, this is 60 and 80. What are they? 60 and 80, they are both the number of butter cakes across two outlets. So total number of butter cakes. So we're saying we get the total number of butter cakes at outlet A, but it's all 1 and 1, so just multiply by itself. But you add the total number of butter cakes at outlet B. So this is really the total number of butter cakes across, as in when outlet A and outlet B combine. So it's total. And this is same, total number of chocolate cakes, and this is the total number of fruit cakes. Right. So we can say it's actually the total number of each of the cakes: butter, chocolate, and fruit cakes respectively. And it's both outlets combined, so we don't have to talk about outlets. We can just say it's total number. Yeah, there we go.